There are many ways to go about explaining black holes. What are they, where they come from, what they do, and many other topics. But let's start out with where do these things even come from? There are stars that range in many sizes, from small to large, with our sun being about an average size. Any star that is the size of our sun or smaller will go through a couple different phases before it finally dissipates into nothing. What will happen with our sun is the nuclear power in the core will eventually give out, and the core of the star will begin to contract. This contraction causes heat and pushes the outward layer very far into its normal reaches and its normal size, causing a red giant. The red giant will lose its fuel and shrink actually back into what we call a white dwarf. White dwarfs are small and burn relatively coolly compared to other stars in the universe. The white dwarf will eventually run out of its fuel and then dissipate into nothing. Much larger stars, however, will not be able to push out because of the gravity, even though the contraction in the middle will become very, very hot. They are so massive that they are unable to support their weight, they become unstable, and they collapse. Some of them will collapse into what we call a neutron star. Neutron stars are about 20 miles in diameter, but they are very, very dense. A piece of a neutron star that is just the size of this rock can weigh as much as Mount Everest. They are very, very dense, and they have a very high gravitational field. But when a star is even more massive and collapses, it cannot even hold its weight to form a neutron star, collapses even farther into a point that we call a singularity. Singularity has no dimensions. It has no height, no length, and no width, but it is there, and it is very, very heavy. Its gravitational field is so strong that not even light can escape it. This rebound and curvature of space-time, which traps light, is what we call a black hole. Black holes are very, very powerful. They are very difficult to understand. We don't know a whole lot about them, but we are finding out more and more every day. They are called black because they go to a point of no return of light called the event horizon. A good way to look at this event horizon, and a very common anomaly made, would be to look at a waterfall. When you're paddling in a waterfall, or imagine yourself paddling through a stream that has a waterfall at the end of it. You have a certain amount of power that you can put into paddling. Once you get past the point of the stream that it's going so fast that you can no longer paddle farther upstream no matter how hard you want to paddle, that's called the event horizon. It's the point of no return. So you don't feel anything special, nothing special really happens, you just cannot go back to where you started at. And you'll eventually fall down into the black hole or the bottom of the waterfall. There are different sizes of black holes. They can range anywhere from microscopic level that we can't even see to sizes of supermassive black holes. Give a few examples of these size differences. Something that many people were scared of during the Large Hadron Collider. They were going to collide atoms and actually see if they could recreate the beginning of the universe and see what happened. Many people were scared that this would create black holes that would actually be small enough to sink to the middle of Earth and engulf Earth, basically. Though this never happened because they were too small. They did occur, they did form, but they dissipated almost instantly after the explosion. Black holes, though, larger ones that do form from stars collapsing, can actually combine. They can engulf other stars. They can do many things to become larger, heavier, and one of them is combine and form what we call a supermassive black hole. Supermassive black holes are something that we think are at the center of almost every single galaxy. The reason that they believe this is because when we look at the center of galaxies, they all seem to be rotating around a single point. But we can't see the single point because it is just dark in that area. So it's pretty safe to infer that there are black holes at the center of every galaxy. If you look at the center of our Milky Way galaxy, it's called a spiral galaxy, and we actually have what's called a quasar coming out of the black hole in the middle of our galaxy. Quasar is what happens when a black hole is trying to engulf too much at one time, and it actually emits gamma rays out of the north and south or polar ends of the black holes and creates a very, very, very intense and very hot gamma ray burst out of either side. As far as scientists are concerned, we have nothing to worry about for these. It would be a very microscopic chance of these ever hitting us. But those are the basics about black holes. They form from very massive black stars. They're different sizes, there are different aspects about them, and they are very, very, very little understood about them. But like I said, many scientists are working on understanding more and more about them and what they do, and if any of them are in a or if we are in a dangerous position to them. So that's about it for black holes. Thank you.